Okay, what I'm going to do is show you how we go about doing measurements. When we load up a file, the first thing we want to do is click under File and then Open, and then we are going to open our baseline file. And with our baseline file, the first thing we want to do, because right now we see the display is a little bit crazy, so the first thing we do is we click on the display pull-down menu and we go to auto scale horizontal. And it still looks kind of messed up, but you'll see we'll fix it in a second here. The next thing we want to do is click on display auto scale waveforms, and boom, there we go. So those two steps, first display auto scale horizontal, then display auto scale waveforms. Alright, the first thing we want to do is pick the three myograms we're going to analyze. How about Huey, Dewey, and Louie here? So in order to analyze these, we have to zoom in close. So we're going to go down into the right hand corner, click on the magnifying glass icon, and this will allow us to hold down on our left button, and you'll notice I'm drawing a box extending it around the myogram. I'm just doing the force side of it. It's going to equally amplify both the stimulus and the force channels. When I let go, you see now that I have one myogram, but I'm going to get even closer so we can get a very accurate measurement. So I'm going to use my magnifying glass again, can click on it here, and I'm going to start in the up and left, pull down with my left button, and now I've isolated my myogram. Okay. The first thing I want to do is I would like to measure the latency phase, so I'm going to use the I-beam right here. When I click on the I-beam, now we can highlight from the starting point here to about right. This is too far, this is too soon, so about right there. That's just when the slope begins to change. We read off our delta t, and I get 0.020 seconds. So that's the latency. Contractiles measured from the end of latency to the very middle top of the peak. Again, I read delta t, and I'm getting 0.084. And the last measurement is relaxation, and that is from the peak to when it becomes fully relaxed. And this can take quite a while on some. I don't have a lot of respect for this measurement because it is easily, some variables are in here. The tighter your string is, the longer it takes to relax, but I'm just going to call that my relaxation phase. And again, I read that as delta t, and I'm getting 0.251 seconds. And then finally, the measurement of amplitude is going to be using this peak-to-peak measurement. So we highlight from here, and now the computer finds a minima, it finds a maxima, and it's presented here. So we got 42.19 grams of force. Now, that is because the transducer is calibrated in grams. It can be changed into newtons, but this is an entirely optional step. And to convert to millinewtons, all you have to do is take this 42.19, or this gram force measurement, and multiply it times the acceleration due to gravity, which is 9.82 meters per second squared, and you would have the force measurement. And that's all it is to do a myogram. We can even click on this little scroll triangle here after we've completed our measurements, and we can scroll ahead to find the next myogram in the set. And we're waiting. Here we go. And now we're going to repeat our measurements. So first was the latency, which was from the onset till the onset of stimulus, or the very left part of the red blip, to where the blue begins to rise. And this time I'm getting 0.020, and it's exactly the same as the last one. Then I'm going to highlight here to get the contractile phase, and I've got 0.087, relaxation phase, from the peak down to where it's relaxed. This time I'm getting 247, And finally the amplitude, where I just swath over, computer finds a minima, maxima, presents it in the blue, channel 2 peak to peak, and it's 42.53.